Polymorphism in Haskell is the mechanism for defining generics. That is, functions that can be used at more than one type, even with the same definition at each type. Let's look at some examples of this in action by taking a look at the GHCI prompt. Here we see reverse applied to a list of integers. Here we see it applied to a list of lists of booleans. And you can see that that function has the same impact on both of those. What it does is reverse the list. In a similar way, we can take the length of that first list, 2, 3, 4, and we can take the length of the second. And we can see that those, so length can be applied to lists of any kind, giving an integer. Reverse can be applied to lists of any kind, returning a list of the same type. We can also do more complicated things. We can take lists of two potentially different types, and we can what's called zip them together. So we can take a list of integers and a list of booleans, and we can zip them together in a single list where we pair up corresponding elements. So the first elements 2 and true are paired up, the second elements 3 and false, the third elements 5 and true, and so on. And there's a corresponding function called unzip, which takes a list of pairs such as this. I'm just going to copy it because I'm too lazy to type it again. And what it does is give us back a pair of lists. That it unzips those pairs into two lists of single elements. Just to reiterate, length can be applied to a list of any type, yielding an integer. We've seen that. Reverse can be applied to a list of any type, and that gives a list of the same type back. And we've seen zip and unzip can be used to zip together two lists of single elements into a list of pairs, and to unzip a list of pairs into two lists of single elements. And as I said, the way these are described, it doesn't say anything about the type of the elements in the list, for example. They could be of any type, whatever. How does that get expressed in Haskell? The answer is it's by using type variables. Just as we're used to the idea that a variable in an equation, in a function definition, stands for an arbitrary value, a type variable stands for an arbitrary type. So we can read these types as saying length takes a list of elements of any type to an integer. Reverse takes a list of elements of type A to elements of that same, a list of elements of type A. It doesn't change the elements, it just changes the order they're in. And zip takes lists of type A and type B and gives us back a list of pairs where each pair has an element from A and an element from B, and unzip does the reverse. So this is the, as I said, these variables stand for arbitrary types, like ordinary variables stand for arbitrary values. So for example, reverse, one example of a type of reverse is that it takes a list of integers to a list of integers. And one type of zip is that it takes a list of integers and a list of lists of bool and gives us back a list of pairs where the first element is an integer and the second is a list of bool. So these types describe to us the generic nature of the functions. Now, as it stands, we haven't looked at the definitions of these things, and we'll do that in the next block. But in a sense, it doesn't matter about that. What these types tell us is how we can apply these library functions, and we can apply them at any particular type that fits the type descriptions we see here.